Hello students, this is Subhan sir. Today we will proceed with our next exercise 1.2. So first question of exercise 1.2. The question is, state whether the following statements are true or false. Justify your answers. The first one, every irrational number is a real number. Okay, first question is every irrational number is a real number. So we have to write whether the statement is correct or not. So this one is correct, true. The reason is all irrational as well as rational numbers are in the category of real numbers. That means real number, we can write in a reason, real number contains all rational numbers as well as irrational numbers. Now the second point, every point on the number line is of the form root m, where m is a natural number. So it is not correct because all numbers are not perfect squares. Okay, so we can't say that every point on the number line is of the form under root m, where m is a natural number. Okay, so suppose if we write 7, so 7 is not a perfect square. That means the square root of 7 is not a perfect whole number. So here you will write false. In reason you write because every real number is not a perfect square. Also, we cannot find square root of negative integers. Okay, we cannot represent square root of negative integers on the number line. So that reason also you can mention here. We cannot write square root of negative integers on a number line. We cannot write a square root of negative integers on a number line, or we cannot represent, we can say write or represent, any word we can use. Okay, so this statement is false. Third point, every real number is an irrational number. So in the first point what we have written, that real number contains all rational number as well as irrational number. So every real number is an irrational number. That is not correct because some real number may be a rational number also. So we can write here false because real number contains rational numbers also. Because real numbers contain rational numbers also. Now moving towards the next question, question number 2. Look at the question. Are the square roots of the all positive integers irrational? If not, give an example of the square root of a number that is a rational number. Okay, that means the question is that every square root of a positive integers is irrational. Okay, the question is that we have to write whether the square root of all the positive integers is an irrational number. If not, if it is, suppose it is not a correct statement, then we have to write an example also. So you have to write no, because square root of 9 is 3. Okay, under root 9, the value of 9 is 3, and 3 is a rational number. How 3 is a rational number? Because 3 can be written as 3 upon 1, that means P upon Q form. So 3 is a rational number, so this statement is incorrect, that is not correct. Third question, show that root 5 can be represented on the number line. So to solve this question, first of all we will draw a straight line representing a number line. Okay, we draw one straight line representing a number line, that's it. Now mark the points. For example, from this 0 we have taken, na? So 1 centimeter I will mark some points. Here 1 centimeter, 1 centimeter, then 2, okay, then 3, 4, enough. Okay, that is a number line. Here 0. Here we will take 1 centimeter. 1 centimeter distance is there between the points. Okay, so here we will take A point and here B point. They all are having 1 centimeter distance. Okay, so if suppose here 1 is there, then ultimately 1 plus 1, here 2 will be there. Okay, so here I am writing 2. Now you see what we will do in this question. First of all, we will draw the perpendicular on this point, A point. Okay, this one, sorry, A point, no? So we will draw one perpendicular over here, and that should be 1 centimeter only. Okay, just take a measurement and it should be 1 centimeter. Okay, now after this we will join this point with another one. Another point, that means O point. Okay, now here is also one, this one is also 1 centimeter, so it is also 1. Okay, if we apply Pythagoras theorem in this triangle, we will get root 2. That means this hypotenuse represent under root 2. How it represent? OA square plus, we will take one more point C here, OC square, that means 1 square plus 1 square, 1 plus 1 2, and the value of hypotenuse will be under root 2. Similarly, another perpendicular we will draw on this point. Okay, and again we will join this point here. Okay, mark it as D. It will represent root 3. Okay, now again we will draw another perpendicular, then we will join this perpendicular. Okay, it should be 1 centimeter only. Okay, 1 centimeter. Then again we will join it. So it will represent root 4. Okay, again we will draw one perpendicular over here, and we will join this point with the O point. So it will represent root 5. Okay, and here D point, E point and F point. That means OF represent root 5. But how to represent this F point on the number line, that is a matter of concern. So how we will plot this point on the number line? First of all, we have to take radius OF. We need to take radius OF. Okay, with the help of compass, from this F point we will draw a circle. Okay, and then we will get a point over here, just about the point of 2. Okay, over here, and this point will be root 5. That means here this point will represent root 5, the value of root 5. Okay, so we can see that 1 plus 1 from B point, somewhere here this point will represent root 5. Okay, now we will write the steps of construction and the steps involved in writing root 5 on the number line. First of all, what we have done, we have drawn a number line. So first of all, we draw a number line. Okay, second point, take a point O and mark the points A and B, which are at a distance of 1 centimeter from each other. Which are at a distance of 1 centimeter from each other. Okay, then we will write draw. Then what we have done in the next step, we have drawn AC perpendicular to OA. So AC perpendicular to OA. Then join OC, and OC will represent what? Root 2. So OC equal to root 2 centimeter, we can say. Similarly, third point, draw CD perpendicular to OC, then join OD, and it is equal to root 3 centimeter. Fourth point, draw ED perpendicular to OD, then join what we are going to join? ED perpendicular to OD, then join OE. And OE will represent root 4 centimeter. Now fifth point, draw EF perpendicular to OE, then OF is equal to root 5 centimeter. But now we will represent this root 5 on the number line by taking OF as radius, draw an arc on the number line. So draw